Morning everyone. Now I am speaking about the parity violation energy difference calculation of heteroisomers. Okay, life consists of macromolecules such as protein, sugars, DNA, RNA, and biopolymers. Under all these cases, the enantiomers always quantitative because only few, in very few cases, the amino acids and also the other basic materials, they follow the enantiomers properties. For example, the sugars, they have DL, and also for the amino acids, LD. Yeah, while forming the alpha helix supramolecular structure for DNA and also the peptide, the sugar chosen D, the amino acids chosen L. Up to now, we doesn't know the reason for this, but every molecule is having the geometric arrangement of atoms, at least 2 enantiomers. In that level, we have some energy difference between the enantiomers that is caused by the weak neutral current mediated by the Z boson that we called as parity violation energy difference. Yamagata in 1966 used the scientist for speaking about the parity violation energy difference of the molecules which he calculated in the L amino acids. And also for this, for the biomolecules are the complete interest for causing this effect. In fact, a reasonable prediction of the effect is lagging in most of the PVD calculations. The PVD calculations of rigid chiral compounds that are already known in literature and also the practical synthesis that we are going to deal in this topic. The results may be in general interest for prebiotic chemistry because for screening a possible structures to go on further in the prebiotic chemistry. The experimental which we used is the geometry optimization we made with the Gaussian 9 with the basic sets B3LYP C630GT. The other things we used the drag 08 program and also the Zora. These are the heteroisomers with no heavy elements, helicins and azahelicins. In this representation, the peak contribution of each atom is evidenced by the color, the green red. Even if helicins possess the higher value of rotary power, the sign of PVD is changing depending on the distance from the center. This reduces the overall effect of parity violation effect. The signs are opposite. The heteroisomers with no heavy elements, that is like a screw-like molecules. Twisted pentazine possess the same sign from all over the atoms. So the overall effect PVD is increased because it's a twisted structure. The comparison of PVD of hexylysine, heptylysine, and also the see for all these cases for the pentazine twisted is having the higher values. That is heteroisomers with no heavy elements, screw-like molecule, phenylene. Phenylene is a well-known compound for everyone. When we increase the number of phenylene groups in the calculation part, the values are increased. The phenylenes possess a lower energy threshold for the rotation around the connections of phenyl group. This might be interested. The switching between R and S enantiomers can occur in low temperature, allowing a possible equilibration between R and S. Enantiomers crystallization might also amplify the enantiopurity of the final product. Helical structures containing heavy elements, Cinnabar. Cinnabar, we know very well HGS, possessing the intrinsic helical structure of HGS. Calculations were effectuated on the portion of HGS chain containing from 1 to 3 mercury atoms. Chains are capped with hydrogen atom, however, their contribution to the PVD is negligible. A double zeta basic set dial was used for all atoms. Higher basic set, the triple and quadruple zeta were tentatively adopted by converger problem were found for molecules 3 mercury atoms. The calculated PVD is 10 power minus 15 for the Cinnabar, but there is no a direct influence on the number of repeating units. These are the values for the simple HGS and also for the increased the amount of HG, which causes the change in the PVD values. The conclusion, the complex molecule containing no heavy elements could provide a useful benchmark for the rapid screening of promising backbone structures. PVD can be calculated for larger system containing more than one heavy atom. Chiral crystals of achiral molecules could be promising for detecting PVD effect. The chiral crystals having large PVD and acting as a catalyst might be responsible of the choice of enantiopurity in living organism. Thank you so much for the organization and Sohan Jitta for the continuous contribution in the prebiotic chemistry and also the participants of the conference. Thank you so much.